We're surrounded by this constant, invisible chatter of information, but if you ever stop to wonder how it all actually works? So today, we're going to pull back the curtain on a process that is so fundamental to our digital world, but, most of us have never even heard of it.
Seriously, think about it for a second. It really does seem like magic, right? You hit a button on your screen, and a physical machine across the room just springs to life. There are no wires connecting them, just empty space. So how on earth does that print job find its exact destination and not, say, your neighbor's printer?
Believe it or not, the answer is something that acts just like the envelopes we use for physical mail. But this is all happening digitally, billions of times a day, right inside your home or your office network.
Okay, so to really get this, we first need to zoom in on how data gets delivered locally. We're not talking about sending an email across the globe just yet. We're talking about something simple, like sending a file from your laptop to your TV, right there in the same room.
All right, so this invisible envelope actually has a name. It's called a network frame. It's basically a digital container that wraps up your data with all the specific info needed for a successful delivery within your local network. You can think of it as the secret to organized, super efficient communication between all of your own devices.
So if we're calling in an envelope, you're probably wondering what's written on it. Let's, metaphorically tear one open and take a look at the anatomy of a network frame to see how it really works.
And what's so cool about this is how much it really does resemble a physical envelope. First up, you've got the addresses. Now, these aren't street addresses. They're unique hardware addresses called MAC addresses, and they act like a specific person's name on a local mailing list. Then there's the content type, which is kind of like writing photos or important document on the outside of the envelope. After that, you've got the payload. That's the actual letter, the data you're trying to send. And finally, and this is really clever, there's an integrity seal. It's a little bit of math that checks to see if the frame got damaged along the way. If that seal is broken, the frame just gets tossed out.
So why even bother? Why have this whole separate local delivery system? Why not just use the internet's global addresses for everything? Well, the answer is all about speed and efficiency, and it really comes down to one key device.
And this quote right here, it just nails the core reason. See, the traffic cop inside your local network is a little device called a switch. It might be that little box your router is plugged into, or it could even be built right inside the router itself. And this switch has a very, very specific job that relies completely on these local envelope addresses.
Let's stick with that mail analogy for a second. If your entire office building is your local network, then the switch is the mailroom clerk. Now that clerk doesn't need to know your home address in another city, right? All they need to know is your office number to get the mail to your desk, fast. The switch does exactly the same thing, but for your data.
So here's the crucial part. A switch operates at the local delivery layer of the network, which geeks call Layer 2. It's designed to only look at the outside of the envelope, the frame. It just reads that local MAC address, points it in the right direction, and sends it on its way. It completely ignores the letter inside, and this specialization is what makes delivery inside your own network incredibly fast.
Okay, this brings us to a really, really important distinction. We need to put the envelope and the letter, so the frame and the packet, side by side to see exactly how they're different and, more importantly, how they work together.
This chart breaks it all down perfectly. On the left, you've got the frame. That's our local envelope. It's working on Layer 2, the local delivery layer, and it uses those local MAC addresses just to get from one device to another in the same building. Now on the right, you've got the packet. That's our long-distance letter. It works on Layer 3, the network layer, and it uses global IP addresses to travel all across different networks, like the entire internet.
And here's the beautiful part of how they connect. The frame is really just a temporary taxi. As soon as it delivers the packet to the right device on the local network, like your printer, the frame is opened up and just thrown away. Its job is done. Poof, gone. And the packet that was inside is then processed.
Now, I know this might seem a little technical and abstract, but I promise you, this whole process is happening all around you all the time. Let's take a look at where these frames are constantly at work in your daily life. Every single one of these actions relies on frames. That print job we talked about at the very beginning, that's a frame. Sending a photo to your partner's phone over the same Wi-Fi, a whole bunch of frames. Streaming a movie from your laptop to your TV, we're talking millions of frames. It is the absolute foundation of all local digital communication.
And look, we're not talking about just a few here and there. On any active home or office network, there are literally billions of these invisible envelopes being created, addressed, delivered, and discarded every single day.
It is a truly staggering amount of hidden activity.
So, the real takeaway here is that this simple concept of the frame, the local delivery envelope, it's not some minor detail. It's a foundational building block. And once you really grasp this, all sorts of other networking concepts, like how switches work or how the internet itself is structured, they all start to make a lot more sense.
So the next time you hit print or you stream a video, just remember that invisible mail service, working tirelessly in the background. And it really makes you wonder, doesn't it? What other fundamental processes that run our world are hiding right there in plain sight?